I'd like these, the x values in numerical order. Okay. And these guys, these sets of things in numerical order as well in the mapping. If you notice, every single time I do a mapping, I do an oval. Okay, I write domain and range on the bottom. I draw the arrows. They're arrows, not just lines. Okay, if you do it the way I do it, this is what you would see. Okay, you might try to represent it a different way, but here's the fact. If you just do it this way, okay, hold on. If you just do it like this, that is not a mapping if you put a table in it. Or if you do it this way, where you outline it, that is not an appropriate mapping. Okay, that's a table. That's a different kind of table. Okay, but that's still a table. If it's connected in the middle, it's still a table. Please just do it the way I do it as my recommendation. Don't try to ad-lib it unless you specifically ask, can I ad-lib it like this? Can I change it like this? And I'll let you know whether that's appropriate or not, because the different way you represent it means something totally different. Like right now, if you drop that line in the middle, okay, and you're not talking about two so totally separate pieces, you're visually representing it something totally different. Okay, and that's not appropriate. Okay. Okay. Let's answer these questions. What happens to the pressure of your body as you dive deeper into the ocean? Does anybody know what happens to the pressure? Yes, sir. The pressure increases, right? Yeah, the pressure increases as you dive deeper into the ocean. Okay, because all that water is heavy and it's on top of your body. Okay, does the pressure depend on the depth, or does the depth depend on the pressure? Do you increase in pressure as you go down, or do you go down as you increase in pressure? Which one happens first? Pressure depends on the depth. Okay, with this first set, pressure, then we can say is the independent variable. Oh, no, sorry, I labeled that wrong. Pressure is the dependent variable. Dependent. Pressure is the dependent variable because it depends on your depth. Depth is the independent. Pressure changes as you go deeper, as a result of going deeper. Okay, the dependent variable happens as a result of something. Okay, the independent variable just happens as a standalone thing. It just happens. Okay, and that creates change to the dependent variable. All right, independent. The value of the independent variable. The value of the independent variable determines the output. Okay, it creates the change in the output, and it determines. The independent variable in our world, guys, is also or it's what generates the domain. Okay, the independent variable. Okay, a listing of all the independent variables is the domain. Okay, remember the domain was defined as a listing of all of the inputs. Okay, if we list all the scenarios for the independent variable, all the relationships, all the numbers, all the values, that becomes the domain. Okay, with independent variables, time in our world, okay, is always the independent variable. Whenever you have some reference of time, it's always going to be the independent variable. And the independent variable always goes on the x-axis for us when we graphing. Dependent. The dependent variable depends on the independent variable. It happens. The dependent variable happens as a result of the independent. Okay, happens as a result of the independent variable. Okay, if you're trying to figure out the dependent variable, think about what's the result. What's the result of the situation? All right, examples. Identify the dependent and independent variables in the scenario. Okay, the wording on this is kind of tricky. If you delete the and, put a period there and write it, it's a little bit more clear. Okay. In warm climates, the average amount of energy used rises as the daily average temperature increases. Okay. In addition, it also falls as the daily average temperature decreases. Okay, the amount of electricity falls as the average daily temperature. Again, guys, oftentimes it's easier to find out the dependent variables first, okay, and then backtrack to find the independent variable. So reading it, what happens as a result of the other thing? Does the climate increase as a result of electricity increasing, the usage of what? Or does the usage of electricity increase as a result of the climate increasing? In this scenario, we're using more electricity as the climate outside, as the temperature outside gets warmer because we turn on the air conditioner. When it's warm outside, we turn on the air conditioner, which creates more electricity usage. Okay, the one that depends on the other, the one that happens as a result of the other variable, is the electricity usage. And that happens as a result of the climate, or the temperature of the climate. Okay? Temperature goes up, electricity. Air conditioner is going on, the electricity goes up. Temperature goes down, the air conditioners are off or are used less. That means the electricity usage goes down. Let's read the other one. The number of calories you burn increases as the number of minutes that you walk increases. There is a glaring thing that makes it easier to determine which one's independent right away, because there's a time figure in this description, right? We're talking about the time you walk, right? Time is represented in here, so automatically since time is an independent variable. Another way to look at it is you do not walk more because you're burning more calories, right? You're not walking more as a result of burning more calories. You're burning more calories as a result of you walking longer, right? Which one happens as a result? Which is the dependent? That's burning calories. Which is the independent? It would be time walking. Time, the amount of time you're walking. Okay, again, the time is the independent. Okay, the dependent is the other thing. Another way to look at this, you burn calories as a result of walking. The amount of time you walk is the independent time. The result is the burning of the calories. From the graph below, the independent variable you can see, and there's three ways to determine this. Again, when we read the description and look at the graph, first way to determine this is time is represented in this problem. So automatically, the independent variable is the time. The dependent variable is the height. Second way to look at it is because you have a graph and time is on the x-axis, that means time is the independent variable. Okay, automatically. without even thinking about the situation, time has to be the independent variable in terms of it. Okay. The dependent variable would be the height. A third way to look at it would be putting it in context and just talking about it in context. Okay? The height of the ball is as a result of time passing. As time passes, the result is the ball goes up and down. Okay? Rather than if you move a ball up and down, that doesn't change the time that it's been in the air. Right? The time it's been in the air is going to determine how far up and down it is. That means the height is the dependent. The height is the, rather than the silly one that says if you move the ball up and down, the time is going to change. Okay? Unless you have some magical abilities on time that we don't know. Okay, describe what's happening in the graph. Write down a sentence to describe what's going on in the graph, in the picture. Go ahead and do that now if you would. Just speak like a 3-year-old. This is going to be funny. Ball goes up, then ball goes down. Right? As time passes, we can also say. As time passes, the ball goes up, and then it reaches the highest point, and then it goes down. Ooh, I'm sorry. Okay, this graph represents the price of stock over time. Identify the independent and dependent variables for the relation, then describe what happens in the graph. First, we can say the independent is what to say? Time. In this case, time. Independent also comes from the x-axis. Second one, okay. The stock fall or goes up and goes down based on how long it's been in the market. Okay, as a result of time passing. It changes, the stock price changes as time changes. If we're going to have a clear description of the graph, we need to incorporate the fact that the price goes up, and then it hits a specific peak, and then it goes down a little bit as time goes on. And then it turns around and it goes back up a little bit, and then it goes down a little bit. So price goes up, then down, then up, then down. But what happens, what's the general trend of the graph? What's the general trend of the graph? What's happening? Do you think it's safe to conclude by the graph that it's slowly, progressively going up? Is there a general trend of the graph for it to continue to go up, or will it go up a little bit more, maybe more? Is that a general trend that it looks like is happening? Okay, and realistically, if we're getting a clear picture of what actually happens in the graph, we need to say price goes up, then down, then up, then down, with a general trend of increasing. Does that make sense? I think that's a fair conclusion based on the information that we're given in the graph. Okay, all of this can be decided from the picture from the graph. Okay, you need to express that clearly that there's all these different parts and components of the graph. The general picture of what happens in the graph, that it generally looks like it's going to go. But there's parts of the graph